Alright, so let's do this. I got this sitting on my bench here for a couple of weeks now, and I'm getting anxious to do this. What I want to do is just build it in one take and see if we can do this without making any edits. I did look at this already. This is all in Chinese. I did take this page, both sides, and scanned it in and sent it to Google Translate, and it came back blank. But I know I've seen other people use their phone and they take it and it converts the text immediately, but I'm not a phone person, so let's just wing it and throw this thing together and see if we can get it to work and how well it works. So we have a couple diagrams here. We got a schematic which has our components marked out as C8, R4, and their value. And we have a PCB board. This is the bottom view of the PCB board. We got a few guides here. This is the transformer 1, they call it, T1 right here. This is the bar antenna. You have 100 turns on one side, 10 turns on the other, and they're labeled, so that should be pretty easy to hook up. It's got which pin goes where. It's got some simple color code stuff going on here, telling you how to read resistors, capacitors. So I think it should be fairly easy. Let's do this. Let's try doing this. So here's the PCB board. If you look at it, let's get a pointer here. You can see they got let's see here, these little junctions where you can short them out. That ties in with this A, B, C. So here's A, here's, where did B go? B's here. C, and D. There is a D? Yeah, D's down here. So what we'll do is once we construct it, we'll put our ammeter across these points. We'll put an ammeter across there and we'll measure. If it's 0.3 amps, then we know everything's right. If it's not 0.3 amps, milliamps, then we got a problem on our hands we need to diagnose and fix. But this should be okay. The board's marked for part numbers. T2, T3, T4, T5, transistor 3, transistor 1, transistor 5, 6, 4, and so on. Should be fairly easy. The only thing I'm looking at this I'm not going to do is I'm not going to install the LED, and I'm not going to install R11. I think that's just a waste. What do you need an LED on a radio for? Just a battery killer, in my opinion. Okay, so let's, my iron's warmed up. Let's do this. We need something to dump parts into. Hopefully one of these is good. One of my trays. Thing is, when I say I'm going to do it in one shot, watch, somebody will come and interrupt me, and then I'll have to put everything on pause and step away. So what I want to do first is resistors. I just want to load up the resistors. Wow, look at the color coding on this one. Can you see this? There's absolutely no stripes on it. And a few pathetic dots on this side. Wow. Alright. R1's 200K. Let's get a resistance meter here. 200K should be red, black, yellow. And do I see one? What is this? Quality control. There's the ferrite bar. This one here looks like it might be 200K. $193. Is that close enough? R1. R1. I'm going to start with resistors first and then work towards capacitors. Oh, before I do this, I wanted to clean this board. I remember when I was a kid, all the kits that came used to tell you the first step was to clean the board before you start soldering. And I think I kind of got lost over time. I think it's important to clean the board. Just give it a scuffing. You don't want to go through the solder mask. You just want to clean the copper so it's bright and shiny. Okay, good. R1. R1, R2 is 1.8K. Here's a 1.8K. I gotta test every part because you never know with these kits. Could be mislabeled, could be defective. I suspect some of these kits have substandard parts in them. That's why they throw them together so cheap. Especially when it comes to things like electrolytics. They don't fit very good. Okay. R2, R3 is 120K. So that should be a brown, red, yellow. Brown, red, yellow. Is this it? Yes, it is. $122K, close enough. That was R3. Where's R3 on this? Can anybody point out R3 to me? There it is, between the two cans. All right. R3, R4 is 30K. That should be orange, black, orange, this one here. $30K, good enough. R4. Going to do all the low-hanging stuff first, and then we'll get work our way up, do the caps after the resistors. R4, R5 is 100K. 100K should be brown, black, yellow. Here's one. They got the resistor color chart here in Chinese. These are the colors in Chinese. These are the numbers. Your tolerance, gold is 5%, silver is 10. It's 102K, 2.5% out. And this one was R5? Yes, R5. R6. R6 is 100, it's up here. Okay, 100 is brown, black, brown. Right here is one. 108 point, that's like 8% out of tolerance. And that's right here in the power line too. I'm going to replace this with a decent part first. Let's get a 100K or 100 ohm resistor. Come on. All right, so what's this? That one's even worse. Oh my God. Are they all that bad? They're all 10% out. Unbelievable. It's not just my meter, is it? Let's see here. My meter is giving me problems. Oh, look at that. It's time to clean this switch. Okay. That's a little better. Yeah, that switch in this multimeter is starting to fail. That was R6, okay. R6. And I did order another one, and it has arrived. I'm just not using it yet. I'm just kind of, I was kind of putting it through its paces. I have some precision resistors I bought a while ago, and they are 0.01% tolerance, high precision resistors, and you can buy them. They're not that expensive, and they're good for testing out your test gear. And with a precision resistor, you can not only just check resistance, but you can also check current flow and voltage with using Ohm's law and all that. Okay, so R7 is 120. That should be brown, red, brown. I think this is a 120. But just from checking, I got an HP, what is it again? It's an HP 3468B multimeter. It's a 6-digit or 7-digit or something like that. It's something ridiculous. And it's fairly accurate, even though it hasn't been calibrated in a donkey's years, but it marches right in step with my new multimeter. It's pretty accurate. So R7 was a 120. Where the hell's R7? R9, R8, R7's down here. Okay. R7 is 120, R8 is 100, another 100. This is 100. So I think I forgot to say at the beginning, welcome to the channel, and I hope you're all well. And it's good to see you again. Yeah. Okay, so our 8 was 100. R8, R9 is a 120. R10 is 100. 120. I think I'm missing a resistor here. I don't think I have enough. This is a 1.8K. I don't know why I have a 1.8K. There was only one 1.8K, and we already got that in place. So that one is a dud. I've got a 330 ohms, and that's R11. Okay, I'm not going to use that. And I got one resistor here that has no markings on it. I think that's 100. Let's see. Yeah, that's 100 ohm, and that goes in R10, but we're still missing R9. R10. Okay, and we are missing one resistor. No, maybe not. What's this? If this is a 120, then we're golden. Can't read the colors because they're so bad. Okay, I think that's close enough to a 120. This is BR9. Okay, so we got all the resistors in place. Let's solder. Clean this. So like I said, I got a new meter. Haven't really played with it yet other than just testing its basic resistance and voltage, and I'm kind of attached to my old one. I've had it for probably maybe 30 years now, and it's fairly accurate. The only problem I have is with the the leads, flexing at the leads. These leads are permanently attached. You have to open the thing up to replace the leads and solder them in, but wires break over time from flexing, and then you get high resistance and flaky readings. Now that the switch is going on it, I think I might have to just open it up and clean it with some deoxit maybe. But I'm so used to using it, it's going to be difficult to step up to something else. Did I miss any? Yes. Okay, let's trim some of this. I used to love doing kits when I was a kid. It was quite the learning thing too. Like you learn quite a bit from doing it, building these things. Okay, we got all our resistors in place except for R11, which we're leaving out on purpose. Where's the position for R11? Oh, up here. Okay, capacitors. C1 is a 103. Let's see what we got for capacitors here. So I've got a couple, or I got one extra resistor. Okay. .103. I don't see a 103. Here's a 103. Let's test it on our capacitance tester. I just want to confirm that these are all correct. Okay, this one comes out at 11.12 nanofarads. So it's like a 122. No, it's a 123, not a 103. Should I put it in or should I? No, let's put it in. C1. C1 I think is up here. Let's check this C1. C1, yeah. The silk screen is kind of cut off here. Okay. C1. C2 is a 282, 682. I think I saw that one. This one here, 682, I think. So this one should come back at, let's see here, 6,800 picofarads. This measures out at 8 point, what? That can't be right. It's at 9 nanofarads and it's rising. 9.4, 9.5. This is just from the heat of my hand here. Look at that, it drops to 7. You can't see it on the camera, but I'm going to replace this capacitor. It looks defective. 682. I don't even have that value in stock. 682. Here's a 682. Film. Because this cap is out to lunch. That's a problem with these garbage capacitors. Okay, this one comes out at 0.7 nanofarads and stable. Okay, and this is C2. All right, it's not going to fit the board very good. C2, C3 is 10 microfarad. 10 volt 100, no. 10 volt 100, no. 25 volt, 10 microfarad. For a 3 volt radio, they sure got pretty good caps here. 50 volts, no. Okay, let's test this one. 10.2 microfarads, 5.5 ohm ESR. So that was number 3. Is the board marked for positive? Yes, it is. Positive and negative. C4 is at 223. Okay. It's a 20 nanofarads and climbing. These capacitors are really unstable. 223 C4. Really garbage disc capacitors. The bare minimum. C4, C5 is another 223. Here's one here. I think it's because they're trying to make them so small that the physical dimensions of it is starting to be affected by the temperature. Okay, this one's 22 nanofarads. Yeah, if I heat it up with my fingers, it drops like a stone. That was C5. C6 is 0.47. 0.47. $420 nanofarads, 500 or 53 ohms ESR. It's really not that good. That was C6. And that's the capacitor that goes to the volume pot. So that's going to be passing audio. But it'll work, right? C7 is another 223. $21 nanofarads, 22. C7. So I'm just building it off the schematic and I'm going in order, numerical order. First we did the resistors, now we're doing capacitors. C7. There is no C8? Where's C8? C6, C7, C9. C9, there's no C8. C9 is 100 microfarad, and that's our speaker capacitor on the output of the amplifier. So C9 is positive this way. I don't see C8 right here. What is C8? C8, oh here, it's hidden up here, 100 microfarad. This is a power supply filter. Cap. Okay, that's it. Solder this on. Here we go. thing is, when you clean the board, it makes it so much nicer to solder to, and you don't have any problems with the flux and the solder not sticking. It's a good idea just to give it a little scrub before you start with a scour pad. And like I said, not hard enough to remove the solder mask. You just want to brighten up the solder pads. It probably would have worked fine without it, but is that it? Okay. Oh, I missed one. All right, on to transistors. Okay, so there's two different transistors in this kit. There is the 9013s, which I suspect are just your audio outputs. And then there's the DG201s, which is the, if you look here, got the 913 for transistor 5 and 6, and 918 for transistor 1, 2, and 3, and a 14 for transistor 4. What do we have here? This is a 18, 13, 14, 18, 13. So we got two 13s, which is right. Okay, 13 is 5 and 6. I have to, should we test these? Gives me a little thing here. They're all the same pin out here. Emitter base collector. Let's test some of these transistors. I want to test all the parts before I put them in. Okay, this here says it's a diode. Okay, we got emitter base collector and an MPN, gain of 134. Everything looks normal. Emitter base collector, and this is a 18. 18 was up front, wasn't it? Let's do the 13s first. 18, 13. let's try this again. Gain of 26. Emitter base collector. Emitter base collector. And that goes for the two audio outputs, which is U5 emitter base collector. Pretty sure that's it. Okay, another 13, 14, 13. Gain of 266. Emitter base collector. Everything looks normal. Emitter base collector. Okay. Now this 14, the 9014. VT4 9014. This one's a 14. Gain of 326. Emitter base collector. Okay, everything's normal. Transistor 4, emitter base collector. And the two final ones are 9018. I should have 3 of these, do I? Where's the other ones? 18. I think we're missing a transistor. What does this say in the back? VT1 is 9018. VT2 and 3 is 9018. And I think we're down one transistor. We'll see. VT1. Emitter base collector. Okay. Gain of 106. It's an NPN. Emitter base collector. Okay. Emitter base collector. That's VT3. Let's put VT2 in. And here it is. last transistor. Gain of 125. Okay. Solder this. How am I doing on the clock here? Oh, it's 40 minutes. This is going to be longer than I thought. We're going to run out of memory card before I run out of things to build. I didn't expect me to take 40 minutes up to this point. I'll have to pick up the pace, I think. I wouldn't get a job on the factory line. Okay. Speaking of kits, like I said before, I built well, not quite a few, but a few in my youth. I don't know if you've seen on my bench, there's a Heathkit 10 megahertz analog scope I bought in kit form and put it together and calibrated it and stuff. And I did have troubles with the vertical deflection transistors. I think there's a lot of confusion in the assembly manual on how it went together, and I don't know if I put them in backwards or something, I don't know. And but after I got that sorted, the scope's been working good, and it still works today. It's probably, I bought it in 1980, let's say. So what is it now? It's 41 years old. Still chugging along. Okay, we are just about done. We have a few transformers to put in. Okay, so T2 is red. We know that. That's the, where's the red one? Okay, here's a red one. And they only go in one way. So what I'll do is I'll insert these and fold in the ground tabs. Oh man, come on. And T3. T3 is that symbol there, which is white. This is T3. I'm not testing these. I'm going to assume they got them working. Oh, hard to get in. These holes are, wow. And then T4 would be the last one, which is, let's just check it here. T4 is that symbol. Which is black, and that's what we got, black. And then T5 is the output transformer. Got 3 wires on one side, 3 wires on the other side. So how do we tell what's going on here? We don't know. There's no marking. Well, there is a marking here. And there's a marking here. You see this little nipple on top? And then there's a circle here. So I'm assuming that's the way it goes. But let's ohm this out. According to this, these two should be a coil. Okay, let's ohm this out. Get a continuity tester, actually. This is going to be this one here. (102 ohms there), okay, and then that 103 ohms there. (226 ohms). Okay, I'm pretty sure that's the right way. Let's get this in. Clock's running. Is that it? Some of these only use 4 of the 5. T2, for example, uses 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Make sure I don't miss any. Good. Next, I think, is the volume control. Anything else we need to do? I don't think so. Let's go like this. Fold these over first. Mechanical security. Tuning capacitor only goes in one way. But we have to add in this because we need to attach wires. This goes like this. Okay, to hunt up some hardware. Three screws. Okay, I think these screws are the ones. Now our bar antenna is tangled up. B and C. This is where it gets difficult because if you look here, I'll show you. We got our coil, 100 turns, 10 turns, okay? I'm assuming this side here is 100 turns, this side here is 10 turns. And we got 3 wires, well 4 wires, but one of them is like a center tap. It's not cut. So A, B, you can see A, I don't know if you can see that on the camera. There's a little faint thing of A there. And if I look, let's see here. Yeah, you can see it on the board, A, and then the next one down is B, which you can barely see. This one isn't in. That needs to be in, okay. A, B, C, C, Is that D there? I can't read it. C. This is C, D, A, B. All right. Let's get a ferrite bar. Yeah, that's what I thought. Everything's loose. Oh, I got this backwards. I got to turn this around. Okay, A goes here. We know that. So let's cut this. It's too long. Cut that off. Let's tin it. Let's solder this up. I can't read this. That definitely says B under there. But then it says B here as well. Oh, that's a base. Okay. B. So I think I need to cut this. Let's tin the ends. Continuity. From A. Okay. This one here is C. C goes here. They show this backwards as of what's going on the board here. This is C here, but that is D on that winding. I don't know if it makes a difference. I don't know. What are we going to do? Solder this one. All right. I'm putting C here. And this one I'm putting here. D is at the base of that transistor. D is the base. Okay. Yeah, so that's right. This is the base of the transistor right here. Falling off camera here. Okay, we're wired up. Not pretty. I should have cut those shorter, I guess. And get some hot snot to hold this together. All right, now what do we need to do? We need to hook up a speaker. Let's do some of this. Let's get a hot glue gun going, heat it up. We're at the 1 hour mark, but we're on the home stretch here, so. So I assume these two yellow wires are for speaker. All right. Does it matter which way it goes? Let's put it this way. Oh, that's crappy. We got some lousy casting, plastic casting here, so we gotta trim this. That's better. I guess I gotta wait for it to cool. What? Come on. Wire's not that hot. All right. I forgot to solder one connection here. Look at that. Bad, bad, bad. So we need to, okay, this pad here is GB minus, so that would be the negative part of the battery, positive part of the battery here, and there's two speaker connections, and then there are 4 jumpers. Okay, so let's Can't put that knob on yet because it'll block everything. Yeah, we'll wait. This is a positive wire and a negative wire. Okay, positive. These wires are very thin. I guess that's all we need. Three-phase these. Okay. Put the volume control on. Guess it's not polarized. Now I need a screw. All right, so we need an ammeter. We can do that with this. Hang on, before we do that, let's do this. Mount that speaker. I want to mount this. Just so it doesn't slide around. Okay, 3 volts. Turn this down to 3 volts. Good enough. Okay, our radio's on. Let's connect negative, negative, positive. Now we should have 300 microvolts or microamps at A. Where is A? C, A is right here. .8. 0.8 milliamps, okay. B should be 0.5 milliamps. And we're getting 1.1. It's twice of what we're getting. C should be 2 milliamps. Oh, we're getting 5.8. Something's wrong here. D should be 1.5. We're getting 13 milliamps. $11 milliamps on D. C. A is 0.7. Let's solder A together. All right. Where's B? B's right here. Getting 1 milliamp on B, which is twice what it says it should be. C. Okay, what do we got?
Over the next few weeks, but right now, I'm just loving every warm weather. Happy to be here once again for 2 to 9. And then next week, I'm going to be back on the 9 to noon show here on 652. I'm actually going to be doing this.
Well, it's working even though those current readings were way off. I don't understand that. So let's do our final bit of assembly here. And then we'll do an alignment. How does this go? All right, let's put this on. Oh, it's sticky tape. wonder how long before this falls off. It doesn't even fit. Kind of cheesy there. Okay, this thing goes like that, so I think this... I'll put the screw in. It's tight. This is just a sticker, eh? Let's see if we can get dial accuracy on this thing. Okay. Rid of this. There is a hole here for a screw, but I don't see the hole being open. It looks like it's plugged with plastic. So I don't know if that's a defect in the molding or what. Let's see if we can get a screw in there to hold it down. I don't think it's going to go in though. Where are we at here? Hour and 20 minutes. Ooh, taking a while. I think it's in. I don't know, I don't want to over torque it. This has to come up. All right. Where is... Oh, I think they go like this. Oh, hang on. This will be my positive, and this will be the negative. So I'll put this on the negative side. Like this. And this one will get the positive. Wow. All right, sorry for the interruption. Just going to strip some more wire off here. And this goes around the positive. And I'm going to solder this right now before it flies off. Same for the negative. Okay. Should be done. No, we're not done. We got one more step. And tell me I put this together backwards. Yeah, I think I did. It's supposed to go like this. Oh no. Okay, let's change this. Let's pull this out. Pull this out. Let's swap these two around. This one here should reach. Just don't want to make sure that wire doesn't get pinched under something. Okay, put this screw back. Okay, we're done. Let's battery it up and tune it. So that took me probably an hour and 25 minutes total, I think. And we'll get some batteries and then we'll set this up. I was just looking. It's very stiff. Oh, that's not good. Pretty poor, pretty poor. I think I'm going to take this board out and I'm going to tag those lines down, those antenna wires down with a little touch of hot glue just to, because they're rubbing on the, on the tuning. This is not working properly. Let's put a little hot glue. That might work. I think this thing here might be sticking up too, this one tab. I didn't fold it over and push that down. Okay, let's try this again. It's very stiff. I think I'm having a problem with the... see, it doesn't even want to come off. With this red thing under here is really messing me up. Loosen this, loosen this. See, that's tight there, and the capacitor can't go any farther. I'm going to make an adjustment to this plastic. Take this off. Oh yeah, I glued it. What I'm going to do is I'm going to just adjust this here. Make some more clearance. Just about done. It's not going to make any difference. It's not going to help me out any. Maybe a little bit. We'll see. We'll see how this works. Okay, this wire needs to get out of the way. Put this back in. Still stiff. Packaging is tight on this thing. There is slots that the board sits in, and I can't get. There we go. Okay. This screw doesn't even hold anymore. There.
And doing that, by offering up an additional layer of mental health support through the program. A text message in from John who says he's been a paramedic, a firefighter, a police officer. Specialized care absolutely needed for the first responder.
It's actually coming in pretty good with no alignment whatsoever. So let's I'll shut tape off here, and I'm going to set up the signal generator. We're going to start feeding it some alignment tones. All right, so we're set up with a loop antenna for my signal generator, feeding it a 455 kilohertz signal. I got the signal turned right down to nothing. Ammeter. Let's turn this on. And we are drawing 20 milliamps. I don't understand why it's so high. Judging from what this says, it should be 1.5, 3.5, 4, about 5 milliamps total. Even with the LED. Well, the LED wouldn't draw much. But I'm at 20 milliamps. And
you will want to use extra caution. Maybe take an alternate if at all possible, because it will be backing up quite significantly.
anyways,
Of a collision in the south on Windermere Boulevard at the Anthony Henday.
this thing is really not. Let's turn the lights off here. Let's start feeding it a signal. That is really poor. I'm feeding it at plus or minus 30. So let's go through these two. Turn down my signal. Let's signal. What's going on here? Picking up all kinds of interference. Okay. Let's set this to how does this tuning dial work? Well, let's feed it a 600 kilohertz signal. Okay, nope. Okay, so we got a 600 kilohertz signal. Let's see if we can find it on the band.
And fellow Canadians. Also broke.
There it is.
Yeah, thanks.
It's right at the bottom, and it's supposed to be, oh, let's see here. It's right at the bottom. Let's turn to 550. And we'll tune this for 550. What happened? This coil is buggered. It doesn't go up or down. There it is. Okay, 550. Let's go to 1600. Very touchy. Very touchy. That's going to be it. See how it works.
Around and I'm seeing a house that I want, but then there's two other people that are shopping around, and then someone snaps up the house before you snap up the house.
Seems to be a little better selectivity. I think it's good. We're done. All right, let's see how this works. Oops. Will this even close? Wow, is that ever cheap?
Absolutely. I speak to my colleagues on a regular basis from other parts of the country, and I just really feel for the buyers who are trying to find a home in a place like the Ontario marketplace, where not just Toronto, but
From the Global News Radio Sports Desk, I'm Dave.
It's working. Not the greatest thing on the planet, but it works. I don't know what this is. Is this a manufacturing defect? They do have a attachment for a lanyard, and I thought I got a lanyard with this. No, I guess I didn't. I thought I saw one in the bag. Maybe I was mistaken. No lanyard. Oh well. Well, there it is. Radio kit built in an afternoon. Took me a little over an hour, hour and a half, close to an hour and a half. Not the best performer. I don't know what that's for. Is that another hole there for an unknown reason? There's the diode I left out, I admitted. And yeah, I think that's a manufacturing defect. But anyways, there it is in its glory. It's built. Anyways, thanks for sitting here watching me fumble with this stuff. And if you want to get one for yourself, I don't know, it might be fun. I think I enjoyed putting it together. It was kind of entertaining. So that's a nice little unit. Too bad it just does a solid performer. All right, take care. Thanks for watching.